Okay. I attended a public lecture for Georgia Tech's first Ig Nobel Prize, which was presented to Dr. David Hu and his team, who were the first group to model urination in mammals and to study the hydrodynamics of urination. His research began as a casual curiosity. How long do elephants pee? How long do small mammals pee? How long do I pee and my own children pee? And these models, it led to the idea of wondering how urination patterns vary and are similar. And he thought to himself that there might be a universal model for mammals and there might be some sort of scaling law to unify how long all mammals pee. So he and his team used a high-speed camera and they were able to develop equations modeling the length of the urethra, the volume of the bladder, and as well how gravity and these volumes and flow rates all contribute to giving an average urination time for about 20 seconds for all mammals. And as a result of his research, he hopes to design more efficient fluid containers, specifically ones using gravity, such as water towers and drinking backpacks. So as you can see here are two different mammals, a 5-kilogram dog and a 5,000-kilogram elephant. And the dog has a bladder of only 0.2 liters, while the elephant has a bladder of 18 liters. But both urinate for about 20 seconds, which he thought was interesting. So he used that observation and subsequent studies to kind of come up with like a generalized urethra bladder model. And the length, the diameter, and the volume of the bladder are all in a constant ratio. And in this figure, you can see here that as mass increases, these measurements here also increase and are on a linear trend. So from his studies, he primarily used Torricelli's law, which relates the speed of fluid flowing out of an opening to the height of the fluid above the opening. Basically how the pressure and the height and the size of the opening all contribute to flow rate. And he decided that urination duration is nearly constant in mammals for two reasons: the cross-sectional area and the faster flow speed, which is basically Torricelli's law represents exactly what he studied. And he was able to develop a law of urination, which basically is just relating time to mass and these other variables that he these other constants that he has in the equation. Okay, and so his research was publishable because he was the first to do such a thing and no one had thought of such a interesting model before.